Our focus in this video is to find a hole in a graph, which is a point in the graph that the graph never really actually touches. So I'm going to start the same way as I always do. If I can factor this, I'm going to factor this. So the denominator is x minus 3, x plus 3, because it's a difference of two perfect squares. The numerator is x plus 3, x minus 2. And now we're going to go ahead and see what we have for a hole in the graph. Well, a hole in the graph stems from common factors. So there's the common factor right there, which means we have a hole in this graph. And again, like I said, a hole is a point, an x value and a y value. So I'm going to take that factor and set it equal to 0. Therefore, I know that the x value of the hole is negative 3. So to find the y value, I'm going to ignore the common factors, and I'm going to put in a negative 3 for x. So again, what I did is I plugged in a negative 3 here and a negative 3 there. So the y value, so this is the y value, is going to be negative 5 on the numerator, negative 6 on the denominator, which means it's a positive 5/6. And with a hole, very often we do have a y value that is going to be a fraction. I'm going to do one other piece here, which is the horizontal asymptote, which seems to be the one that is one of the harder ones for us to find. The horizontal asymptote, we're going to go back to this piece right here. We're going to look at the leading coefficients. Since the x squares are the same, then I can find my horizontal asymptote. Y equals, I'm going to take the coefficient of the numerator and the coefficient of the denominator. Therefore, the horizontal asymptote is 1. If I needed to find a vertical asymptote, it would be right here, the remaining factor. X equals 3, which would be the vertical asymptote. The x-intercept would be the remaining factor of the top, so it's going to be 2, 0, because I set that equal to 0 and solve.